Okay, as far as an integration goes for 93, it looks like a fairly simple integration. You know, if I were doing a dx dy or dy dx, it'd be easy. What may not be easy is the region they're talking about now. So I want to just, look at a better picture. And what it says it's squares with the vertices, 0, 1, 1, 0, minus 1, and 0, minus 1. And I want to look at that. And let me just go through that with you. That the point here is going to be 1, 0. The point here is going to be minus 1, 0. The point over here is going to be 0, minus 1. The point there is going to be 0, 1. Right? So we got that. Let me just make sure you understand what I mean by that. 0, 1, 0, minus 1, 1, 0, and minus 1, 0. And the problem with this is, if you did the integration, right, depending how you want to go about it, I want to point out if you're going to do this over here, whoops, sorry about that. Let me get my little red pen out. You'd have lines going like this, I should say rectangles, and the top and bottom are the same until you get over here, and then I'd have to split it to two integrals now. Now, if you did it the other way, if you went this way, the upper and lower, same line until you get this over here. So what direction? I got to split into two different parts. I'm not saying that's bad to do that, right? I would prefer to do that than go to a Jacobian. But anyway, we're trying to learn something new here. So let me get my eraser out. I'm kind of, done looking at my picture, knowing that if I were to integrate using what I've been doing in the past without the Jacobian, I'd have to split it to two different integration problems. So what I want to do is talk about, looking at it, and we'll put the Jacobian down, looking at the problem and wondering what to do with it. And there's a variety of things you could do with it. But, kind of looking at it, one thing is to make a substitution. And I want to point out, just kind of looking at it, maybe let's talk about the lines now, what those lines are. And the lines are just really kind of simple lines, right? Like, y equals, I'm not going to say y equals x equals, they're just straight lines. So y equals mx plus b. So it seems like a linear combination somewhere. So you know what? It may pay to do this over here where you write down a system of equations. Again, this is not unique. What's nice about this, though, I can easily, solve that for y and x. And let's put this down. Add them together. You're going to get u plus v would be 2y. And then I could say, oh, y is equal to u plus v over 2. That was easy. I could also do, let's see, I could do v minus u. Let's write that down. V minus u, well, y minus y is none, and then you get 2x. So I could solve for x. What's x going to be equal to? X will equal v minus u over 2. Let me show you where this is written. We got the, let's see, the y, u plus v over 2, and we got the x, v minus u over 2. Let's go for the Jacobian, and we'll do that. And let's point out what we're looking to do over here. We're looking to do the partial of x with respect to u. Let's write that down. Okay, we're differentiating x equals v minus u over 2, and we're differentiating with respect to u. So what are you going to get? Like v's a constant, you're going to get minus 1/2. Okay? All right, let's put the next one down. dy dv, I'm sorry, partial y, partial v. All right, let's look at that. We're over here, and what's that going to give you? 1/2. If you multiply those two together, you're going to get minus 1/4. All right? Let's do the next one. By the way, let me point out what I just did. I just did this over here. And what do we get? We get minus 1/4. That's right over here. Let's do the next one, and that's going to be partial u, partial, partial y, partial u. Okay, let's look at that. Partial y, partial u is 1/2. All right, let me point out what we just did over there. We just did this. Now we're going to partial x, partial v. I did it again. Let me get a eraser out. Okay, partial x, partial v. Get 1/2. What's the product there? It's a quarter. All right, let's go through that. And that's written right over here. Minus 1/4 is minus 2/4, which is minus 1/2. The absolute value of minus 1/2 is just 1/2. Okay? Let's put our integration down again. And again, it's going to be some thinking still. I mean, we have to think about it. It's going to be x squared plus y squared. So x squared plus y squared. We'll take care of that later, by the way. And then the dA goes down. And what's that going to be? That's going to be the 1/2 du dv. Okay, I got troubles over here. So what are your troubles? I got to get the x and the y in terms of u's and v's. All right, I'm going to start to erase. Kind of done with this business over here. I'm kind of done with this business. But what I have to write down now is x squared plus y squared. And let's square the x first. It's going to be v minus u squared over 4. Then we're going to square the y, and that's going to be u plus v squared over 4. Let's go to town on that. You can get v squared. Oh, by the way, calm down to 4. Minus, that's vu, 2vu, plus u squared. And then let's put this down. Plus u squared plus 2vu plus v squared. Well, I think I can handle that. This disappears, which is good news for me. And what do you get? 2v squared plus 2u squared over 4, which is simply going to be v squared plus u squared over 2. Let's get the eraser out, and let's put that down. So what do you get? V squared plus u squared over 2. All right, I'm going to simplify a little tiny bit. My big issue here right now is that it doesn't look bad. It really hasn't gotten any worse than I had before. But that's going to be a factor of 1/4 on the outside now. Pulling the constant out. And let's talk about the u's. All right, let's talk about the u's. And so if I looked at it, I got to be careful about this too. Let's write that down again. So u, y minus x, and the v was y plus x. And we're looking at the u's now, right? And I'm looking at those points. So y minus x, let me just for a moment think about what I'm going to say over here. U plus v over 2. I got to think for a moment. And the x's are going between -1 and 1, and the y's are also going between -1 and 1. Let me take a look at that. 1. I gotta think. That's a problem with thinking. I'm over here. I'm trying to get the U's and V's. Let me think about this carefully before I say anything. And we're trying to do the U first, right? So let's see, U minus X. It's Y minus X, right? Minus 1 to 1. All right, let's just check. Yeah, I got that. Now the V. Y minus Y plus X. Minus 1 to 1. Okay. Let's see what we got over here. V squared plus U squared. Let's see if we can do that. And let's do one thing at a time. And the first thing I want to do is just this guy over here. And let's just do that. What are you going to get? Well, you can get U V squared plus U cubed over 3. And you're going to evaluate that from minus 1 to 1. What does it give you? Again, this is what the U is. You're going to get V squared plus 1/3 minus V squared. I'm plugging in U is minus 1 minus 1/3. What does that give you? 2V squared. 1/3 minus a minus 1/3 is going to be 2/3. All right, let me write that down for you. 1/4 minus 1 to 1, not V squared, 2V squared. I'm copying this, by the way, plus 2/3 dV. All right, let's see if we can do that. I'll pull this over here. And that is going to be 1/4. It's going to be 2V cubed over 3 plus 2V over 3. Limits integration go from minus 1 to 1. Let's see if we can do that. What do you get there? 1/4. You're going to get 2/3 plus 2/3 minus 2/3 minus 2/3. Let's see if we can do the arithmetic. You can get 4/3. Let's see, plus 4/3, which is going to be 1/4 times 8/3, which is going to be 2/3. All right, 2/3. We're done. Thank you.